The New Zealand forest industry is the third largest export earner for the country and generates $5 billion annual gross income. More than 50% of the total harvest is exported as green logs. Logs are often infested with pests. If not killed, they can colonize the important country, harming New Zealand's reputation, the forestry industry, and the economy. One of the current treatment methods is based on methyl bromide fumigation. The chemical is an ozone-depleting agent. At the current time, an alternative, non-chemical method is in high demand. Our research proposes to treat export logs using the Joule heating effect. In 1953, Fletcher and Downs of the United States Forest Service used this method to heat green logs for veneer peeling. A log, when freshly sawn, is electrically conductive. The current passing through the log generates heat that causes a relatively fast temperature rise. The objective of our research is to develop a computational model that can explain the Joule heating process in wood, estimate the amount of required energy, and predict the temperature rise. To understand the Joule heating behavior, we started our research by heating flat boards. The results showed that the temperature rise of the boards was not uniform. The wood closer to the bark conducted more current and got hotter than the wood closer to the center of the tree. Radiata pine has a relatively dry central part, called hardwood, and a much wetter external part, called softwood. Some boards contain softwood and hardwood. To understand how the different parts of the wood heat up, we replaced the boards with 3 cm cubes. The cubes were much smaller than flat boards and contained only softwood or hardwood. We measured the cube's electrical conductivity at different temperatures and in 3 principal gradient directions. Electrical conductivity is the property that defines how well a material conducts an electrical current. We derived 3 equations that link the wood's temperature and grain orientation with the electrical conductivity. These equations were used to build a complete model of Joule heating of export-size logs. The model was used to predict the experimental temperature within logs that were pre-infested with bark beetles. After 30 minutes of treatment, all the beetles and their larvae found under the bark were dead. Employing this much cleaner technology can reduce ozone depletion, keeping our environment safer. As an engineer, I am glad that I can be part of this promising research.